And action. What is going on, people of the internet? So, it's Friday afternoon, got a half hour left of work, and I kind of want to just show a little bit about the CNC lathe that I've been running, programming, and operating for about the last 5 months or so. Pretty good progression, not having ever really programmed CNCs before in my career. I've just pretty much done 8 years of manual stuff like this, so pretty interesting opportunity I've had here. Pretty chill environment. They just kind of let me do whatever I want. I don't own any of this stuff. I'm working for somebody. But anyway, I'm in pretty good graces here, and yeah, let's have a little fun. First, I want to just I got this basic program. See if I can get this thing to get to the right frequency. So I got this little thing going on where I'm taking a nut that is normal size, a 3/4 inch fine pitch nylon lock nut, whatever you want to call it. Basically bringing them down. Customer wants them to be, here's the customer's nut, and we couldn't find them on the commercial market, so we just bought normal ones, and we're chopping them in half and making them look all pretty. So that'll give me an opportunity to kind of explain a little bit about G-code and stuff, and like kind of my thought process. It's kind of a weird, it's not a super traditional thing you would be doing on a lathe that's cutting a nut in half, but I mean, it's still, I can explain how constant surface speed works, and different tools, and doing tool changes, and this is actually kind of interesting because it's pretty much line to line with the jaws of the chuck, so not a whole lot of room for error. Anyways, let's yeah, I'm gonna take this part out because it's all done. Kind of working one-handed here. So the chuck is operated by hydraulic foot pedal, close, open. Most of them are just one pedal. This machine is a 1992, so it's super old, and it's got 2 pedals. Kind of annoying, but oh well. So there's our finished nut. I still got to go and deburr it. Kind of just hit on the edges with a belt sander or something like that. But so basically, what I'm doing to set this up is I'm putting the nut in here a little bit, just so it can just bite on a little bit, right? But how am I making it so it's not all wobbly and stuff? I've got this pretty beastly parallel, and I can't really do this one-handed, but basically what I do is I go like this, then I put the nut in here, and then I close the jaws without crushing your finger, and then I can take the parallel out. Very important, because you wouldn't want to turn the spindle on and have this to go flying into the stratosphere or your face. So I'm gonna go and load up a part real quick, and yeah. So yeah, it's a little finicky to demonstrate, but yeah, I'm basically setting the height from the bottom of the chuck, because it's a nice flat surface. I can repeat every time. I was taught this during my apprentice years long ago. Got some coolant on the screen. Sorry, this video is going to be pretty bad. But alright, so we've got the part in there, clamped down. So first thing I'm going to do is go over to handle and turn the spindle on and make sure that it's spinning correctly. If I just click clockwise forward, it tells you need to use both hands. Luckily for me, I have pretty big hands, and I can turn the whole spindle on with just one hand. The idea being that you're supposed to use 2 hands to turn this on, right? But break the rules. There we go. Now my spindle is on, and I can also hit red button here, which will turn it off. but we're gonna have that on. I usually just set it to 375 RPM, and I can, you know, go up or down with this thing right here. But I don't really have to change that too much. So that kind of just stays like that. So as we can see, you might not be able to see, but machinists probably can. It's wobbling like crazy. Yeah, you can see that, right? So I'm gonna try and reset this to get it spinning straight. So, and the air compressor's turning on, so perfect timing for a break. Alright, got it spinning a little better. It's not really perfect, but you know, whatever. It's a nut that's mass produced at a very high speed, or I should say quantity. Tuck my microphone in. Alright, so I'm gonna do this. So let's put this on 0.5. You can kind of see me in the screen right there. What's up? So yeah, this is the terminal basically right here. I'll show you around a little bit. So this is my program called Nut Shorten. Pretty sophisticated, not a super long program. There's just 3 tools: tool 4, tool 1, and then tool 10. So tool 4 is, let's go to MDI, and I'll do a quick tool change code, which is T0404 end of block insert. We're going to hit the green button. You can see the code right there. Hit the green button. So this is the first tool of the program. It's a 120 thousandths wide grooving tool slash part off tool, whatever you want to call it. This one's kind of more of really just for grooving, but it's a nice solid heavy duty. It's not adjustable like this one is. See how this one you could slide in and out via those screws right there. So this one's I'm just using it because it's super close to the chuck, and this one I can't really get too close to the chuck because it has all this overhanging stuff. So out of necessity, I used the grooving tool for parting off the end of our nut. So that's our first tool. Our second tool, which if we go to MDI, which we're already in obviously, T0101, so this is tool 1 call out. And it's different from the CNC mill. CNC mill, you would say T1M6, and I'm not exactly sure the reason why. I think it's because they're just different systems, and to make things easier, they don't cross-pollinate tool change G codes. Or I'm sorry, it's not even really a G code, it's a T code in this instance, but basically an M code. I keep this set up for the lathe. So it's tool 1 and then offset 1, T01 and then 01. So you could do like T0100, but I just keep it at T0101 just to make things easier. So let's hit green again. So now we're at tool 1, which isn't here. That's tool 2. This is tool 1. It's kind of like under it a little bit. It's obviously upside down too. So I accidentally hit the off button. It's just a CNMG 432 series. So it's a 31 thousandths tool nose. And just for comparison, you can see, hopefully see how it's a little rougher radius, but if we go up to here, tool 2, it's more of a fine point. It's a 15 thou radius. I just use that one for finishing stuff off, really, and that's about it. Tool 10, which is really another thing just out of necessity, is just a stupid little boring bar, the same kind of boring bar you would use on like a manual lathe such as this. So it's straight up a boring bar, probably from the 1970s, that I'm using in the 1990s CNC lathe. So what this guy is doing is just basically chamfering the inside once this is sliced off. So that tool is coming in and making the inside of our nut. You give it a chamfer or countersink or whatever you want to call it, so that the threads have a nice smooth lead in, so there's not as many burrs. I still have to deburr those a little bit, but whatever. It's better than like taking it and like sticking it into a drill press with a countersink and risk like, I don't know, tearing your hand off. So trying to have the machine do as much deburring as you can is the name of the game, especially when you're doing production. I mean, that's only like 9 parts. It's not really production by any means, but so let's go back to our program. I'm going to go to auto this time. Yeah, so I'm going to get this thing to, the hertz to line up. I don't know, I think this thing runs on 50 hertz because it's from Taiwan, but that might be BS. It's a 60 hertz screen probably. I don't know. But anyway, it's not a perfect match. So yeah, I'm going to try and like start and stop and pause and as we go to kind of explain what's going on with everything. So yeah, let's see what happens. So first thing, I guess we'll just run through the first section. So this is the name of the program, O1108, or I should say O1108. The O is very important. That's just how the computer knows that's the start of the name of the program, and that always has to be at the top. And all the way at the bottom, oops, go to edit. All the way at the bottom is a percent sign. So that's kind of your top and bottom of the program. M30 just simply means end of the program, turn everything off, and reset to the top of the program just like that. So we're in that kind of a constraint here. So like I said, there's only 3 tools, so it's pretty simple, and they're all separated by this little gap right here. I usually just do that just so I can zoom up and down and find where I need to go really fast. Alternatively, I always put N1, or like N and then a number that corresponds to the tool. So in this case, N1 equals tool 1. So say like I wanted to rerun that tool. Instead of scrolling down, I can go to edit, go to N1, and then hit cursor down, and you can see N1 right here. When I hit cursor down, boom. And that might have been a little confusing, but basically that scrolls down to about here in the program. You know, if this was the top and this was the bottom, I'm scrolling down to a certain point really fast, kind of just like searching it. So if I go to N10, cursor down, that brings us to our third tool. And the reason they're not tool 1s, 2, and 3 in order like that is because it corresponds to the number on the actual tool changer itself, which you can see there's number 1, 2, etc., etc. We're currently locked into tool 10, which you can see the number right there. Yeah, so this is exactly how the program is when it's finished. So when I hit go to auto, let's always reset to make sure you're at the top of the program. I mean, if you start from like the middle, like here, it's just gonna be dumb. It's not gonna do anything crazy. Oh, maybe it is. So yeah, always better to start from the top. Sorry, kind of hard to do this one-handed. I can show you how to home the axes real quick. Go to 0 return. Usually do this in the morning or when you turn the machine on. Let's put this into position mode. Hit the Z home. That homes the Z. which goes this way. And I'll go to 0.5. If I hit X, you can see that one's homing as well. They don't go to 0. Well, if we go to, that's incremental U and W, corresponds with X and Z. I don't really look at that menu too much. I usually just stay on the absolute right there. So, all right, let's get into why we're here. So starting off with the program, it's going to call out tool 4, turn the spindle on. G96 is constant surface speed, which changes the RPM of the spindle. It's just more of an efficiency thing, and you can get more predictable tool wear and stuff like that. So that's why you'll hear the spindle spooling up and down instead of just being the same speed like a engine lathe. So G96, the spindle speed, I have it a clamp or a maximum RPM limit at 600 RPM. So that's just basically so this thing doesn't go crazy and go like 3,000 RPMs and blow up the transmission or something, because it is a very old piece of equipment. That's why I run it really slow at like 75% of its actual speed it probably could run at. Because if this thing breaks, well, then that's not really good for me. So if I hit start here, let's see. Yeah, I'll just do this. Oop. So it's switching to tool 4. Got the door open, so it's gonna get a little wet maybe. Close this a little. I usually just run the door like half open, just enough to keep the coolant like that. So this tool is going to go over pretty close to the chuck, and we're rapiding still G0. I have it paused. And once it gets to Z.1, which is 100 thousandths in front of the part, then we're going to switch to G01, which is controlled feed rate, basically, running in inches per revolution. So F.1 is not 0.1 inches per minute, it's 0.1 inches per revolution, which is basically a good way to think of it is F.001, 1,000ths per rev. That means every revolution of the part, the tool is moving 1,000ths. So the tool mark itself, the spiral going down the part, will be 1,000ths per line. So 0.1 is moving super fast. It's more of just like a slower rapid, and you'll see what that looks like here. So it's gonna feed in a little bit slower, as you just saw. Now it's at its spot where it needs to be. Now X.650, the tool is now going in this way at 0.001 inches per revolution. So it's pretty slow. It's actually really slow, but since it's such a cumbersome tool, it's wide and it's cutting straight in. It's not cutting like a traditional tool would, which we'll see in a second. So that's basically going down. It just cut half the nut off, and so it happens quickly. So I'm trying to explain as best I can. I feed it back up so it's above the part, as you can see there, before I rapid it back home to do a tool change. So we're right here. We're rapiding to Z.1. We've already rapided to Z.1, which was our starting position. So now we're going G28, U0, W0, and turning the coolant off. I already turned the coolant off manually because we were getting soaked. I'm sorry. The coolant already turned off with the program. And now we're getting ready for our tool change, which is tool 1, which is going to happen right there. It just changed. You can hear it, probably couldn't see it. So what this tool is doing is coming in, rapiding in again, stopping at 0.1, but this time we're going minus 0.430. And that's because we've already taken off about that much of that nut. You can imagine it was about that much that's missing now. So I'm not going to call out my 0 there. I'm going to call it at the part. I'm going to call the 0 way out here, so I can just do like basic subtraction and stuff like that to get. Anyway, so wrapping in. Then we're feeding in again, that F.1, feeding in pretty fast. And now it is going to be feeding, see this X.6. It's right now it's at X 1.214. So it's going to go down to X.6. So the tool is coming in this way. And then the tool is going to go out and then back up. You can see that. So I paused it again because it's like happening pretty quickly. So I'm feeding it at 4 thousandths. That's a pretty standard finishing feed rate for a tool, a normal diamond cutting tool like that. And then kind of moving away from the part, up and out of the way, same as before we wrap it back home. Turns the coolant off. That M9, by the way, M8 turns the coolant on. M3 turns the spindle on. So now we're at tool 10, which is our little boring bar, and he's gonna go and cut the little chamfer. So I'm trying to make this video brief, but it's so I have the spindle pretty slow. Well, not super slow. Got the roaring riptide of coolant coming out because I don't have the bright nozzle on it. That's okay. So I'm wrapping to basically above, just a little bit above, basically the boring bar is coming down. It's going to touch. Of course, this Allen wrench is magnetic. It's going to touch. So that little boring bar is basically going to come down and touch the edge of the part, come down and cut a diagonal like that, go in, and then wrap it away. So let's go watch it do that. This is what the G-code looks like. So we're wrapping in again, and we're going to slow it down, G01, so we can control the feed rate, and we're going to be going X.81, which is a little bit higher than the hole. And then this Z minus 0.53 X 0.68, since there's two coordinates being called out at the same time, it's going to cut a diagonal instead of just cutting like straight lines like we have been up to this point. So that's going to be cutting a diagonal 45 degrees. So in we go. Can't really see anything there, so I'm going to kind of show this. And it goes minus point. I've paused it just to kind of explain the ending here. And then the tool is going to go drop down, so it's not dragging out on the finished thing we just cut. So now it's rapided to Z.1, and now it's rapiding back to home. And I just missed it, but it hit the M30 code and went back to the top, and we got our bubblegum light thing that I fixed. Actually, it was all broken, to let us know that our program has finished. So we come in here, get our air nozzle, and try not to kill your ears. I'm going to do it lightly. Because I don't feel like editing the audio. And yeah, that's kind of it. This program, at least. Yeah, pretty cool, I guess. Can open the chuck with my foot. Part should come out. Well, nope, there we go. So yeah, If you look, see if I can get it to focus. Okay, we're not going to get it to focus, I guess. You know. Alright, so there's our finished part. Let's see. See the threads, and you can kind of see the angle that we cut and stuff like that. Here's the part we chopped off. So the nut was about this long, right? And yeah, then we shaved it down a little bit more, got it to the exact height that the customer specified, which is the height of this nut. Pretty dang close, huh? So yeah, last thing to do is kind of just go over to the deburring wheel, and yeah. Yeah, so thanks for watching this video. Hope you enjoyed and possibly learned something new. I mean, I know it's a really old CNC machine with a very old computer, but it's been great learning on it because it's just easy to use, and it's still a really good system. It's just yeah, it's just older. It's kind of alien compared to the newer types of CNC systems. So yeah, thanks for watching.